Good morning, everyone. Today we will see about gypsum products. Introduction. Gypsum is a mineral that is mined in various parts of the world. It is also a product of some same chemical composition, chemical processing operation. Chemically, gypsum is a pure calcium sulfate dihydrate. In short, gypsum is calcium sulfate dihydrate, and which we used for dentistry is a calcium sulfate hemihydrate, that is dental plaster. So the gypsum is converted into the calcium sulfate hemihydrate. Application. So these are the applications for the dental plaster, that is in general use for preparing statues and in construction work, and in orthopedics for splinting and making plaster cast. In orthopedics, the plaster cast which we used for diagnosis purpose is made up of gypsum, and in orthodontics and in orthopedics we do plaster after fracture. For that purpose also gypsum is used. In dentistry for making impression of oral and maxillofacial structures. So the material, the gypsum which we use for the impression is different from the gypsum we use for the making cast. To make mold, cast, dies. Basically, cast is what is cast? Cast is a positive replica of a oral tissue, and impression is a negative replica of oral tissue. So, after making impression, we pour the cast with the help of dental plaster. So, to get a positive replica. So, again, the plaster is used for the making cast, dies, then to attach cast to an articulator, the mounting which we do uh, for the teeth arrangement is done with the help of gypsum or dental plaster. For bite registration, again bite registration is for you people. Bite registration, we record the centric jaw relation. So that jaw relation is transferred to the articulator. So for that again we can use dental plaster and for dental investments. So these are the application of the dental plasters. Then classification. There are various types of classification for the gypsum, but for you people, this classification is followed. That is ADA specification number 25. So type 1 is dental impression plaster. Then type 2 is dental plaster. Type 3 is dental stone or medium strength stone. Type 4 is improved stone or high strength stone. And type 5 is a dental stone with high strength and expansion. So this classification is followed for you people. So after classification, manufacture of gypsum products. So the process of heating gypsum for the manufacturing plaster is known as a calcination. So plaster and stone are the product produced by calcining calcium sulfate dihydrate or gypsum. So gypsum is basically what? It is calcium sulfate dihydrate. After heating calcium sulfate dihydrate, we get calcium sulfate hemihydrate with a loss of water. So that calcium sulfate hemihydrate is called as a dental plaster, and this process is called calcining. So commercially the gypsum is ground and subjected to the temperature of 110 to 120 degrees Celsius to get dental plaster. So that amount of water needed to convert calcium sulfate dihydrate to calcium sulfate hemihydrate. So as the temperature is further raised, the remaining water of crystallization is removed and the product are formed as indicated. So the manufacturing of gypsum product. So here calcium sulfate dihydrate is heated to 110 to 130 degrees Celsius to get a calcium sulfate hemihydrate. After again and the water of crystallization is lost. So after this calcium sulfate hemihydrate again heated or subjected to a temperature 130 to 200 degrees Celsius to get calcium sulfate hexagonal anhydrate. And again this is heated to 200 to 1000 degrees Celsius, you get calcium sulfate orthorhombic anhydrate. So again the alpha and beta, the hemihydrate which we get is again two type, alpha and beta type. So here the plaster and the stone. So after manufacturing, so the basically there is difference in manufacturing process to get alpha or beta hemihydrate. If you do dry calcination, so when you ground the gypsum product and heat at 120 to 130 degrees Celsius up to that temperature, so you get dental plaster. And when you do wet calcination, you get beta hemihydrate or sorry, alpha hemihydrate or dental stone. So there is difference in a plaster and stone. So process of manufacturing, here dry calcination, here wet calcination. So particle size form is again different. For the plaster, it is large, irregular, and when you heat at wet, when you do wet calcination, so wet calcination basically is done in a autoclave or closed vessel where you get steam. So this is the process is called as wet calcination, and the crystals formed by the wet calcination are smaller comparatively compared to the crystals of plaster. These are smaller, regular, and dense. So again, when the crystals are small and regular and dense, the water powder ratio required is less. So you required here only 0.3% of water. Here it is 0.5. So the porosity again, you can see that when the crystals are large and irregular, the product is more porous, and when it is smaller, regular, and dense, the product you get is comparatively less porous. So properties, hardness is less, here hardness is more, and the application, it is used for the used when the mechanical properties are not primary importance. That is, it is used for the diagnostic, making diagnostic cast and for mounting purpose. So here stone, stone is again the process of calcination is different, so the stone is costly compared to the plaster. So the stone is used wisely, like when to make a dies or master cast, when there is actual need of mm, properties, you use stone. Otherwise the plaster is uh, the choice. So powder particles of plaster of Paris. See here, you can see irregular, more porous, irregularly arranged. So manufacturing of dental plaster. So gypsum is ground and heated in an open kettle uh, at temperature of 110 to 130 degrees Celsius. Uh, So the process is called dry calcination, and the crystals are formed by this process. It's microscopically fibrous aggregate of fine crystals with a capillary pores. So these crystals are not very dense, and these are irregularly shaped. So the porosity is more with compared to the dental stone. So dental plaster is more porous. So they are then ground to break up the needle-like crystal and to improve. This improves the packing. So to improve the density, we can ground these crystals, but we cannot improve the density as compared to the dental stone. now manufacturing of dental stone. So in dental stone, gypsum is calcined under the steam pressure in an autoclave at 120 to 130 degrees Celsius at a pressure of 17 lbs per square inch and for 5 to 7 hours. Thus the product obtained is much stronger, harder than the uh, beta hemihydrate. This is alpha hemihydrate. So microscopically, the cleavage fragments and crystals in the form of rods and prisms. So this is manufacturing of the dental stone. So manufacturing of the improved stone. As we know the products of the gypsum, that is impression plaster, then dental plaster, dental stone, then dye stone. So for fabrication of a dye stone or improved stone, here we have to gypsum is calcined by boiling it in a calcium chloride solution. The calcium chloride solution we use for the calcination is 30%, and in presence of a sodium succinate, that is 0.5% of sodium succinate is used. These particles are densest of all three types. So after the control guiding, this powder have an even higher apparent density and yield even stronger set. So the particle which we get after manufacturing in presence of chemicals like calcium chloride and sodium succinate, it's very much dense, and the crystals are arranged properly, so there is less porosity compared to the even dental stone. So the highest porosity is seen with the dental plaster, then dental stone, and then improved stone or dye stone. So and density is increased in case of improved stone. So microscopically these particles are cuboidal in a shape. So setting reaction, again setting reaction in when plaster is mixed with the water, it takes up 1.5 molecule. So setting reaction, when plaster is mixed with the water, it takes 1.5 molecule of water, that is it regains the water of crystallization and become calcium sulfate dihydrate, that is again it becomes gypsum. Gypsum is calcium sulfate dihydrate. The product which we get after calcination is calcium sulfate hemihydrate, that is dental plaster. When we mix dental plaster with water, it gets water. It gains water of crystallization to become again calcium sulfate dihydrate, that is gypsum. So here you can see the calcium sulfate dihydrate plus water, you get calcium sulfate hemihydrate plus water, you get calcium sulfate dihydrate, and the unreacted water is remain, and after this setting reaction causes heat generation, and because of heat generation the excess water which used for the mixing is evaporated, and what after evaporation of water there is a form of voids. So the reaction is exothermic and the same for all gypsum product. This reaction is same for all gypsum product. Though the procedure of calcination is different for different gypsum product, the setting reaction is same for all the gypsum product. So theories of setting. The theories of setting in these there are different theories of settings given by different authors. So the setting reaction of gypsum occur by dissolution of calcium sulfate hemihydrate for the formation of a saturated solution of a calcium sulfate and subsequent aggregation of less soluble calcium sulfate dihydrate and the precipitation of dihydrate crystal. There are following theories of reaction. So here the colloidal theory or gel theory, then hydration theory, and the dissolution of precipitation, that is crystalline theory. So this is widely accepted theory. Crystalline theory is widely accepted theory. So we will see the crystalline theory, that is dissolution precipitation theory. In this, this theory is more widely accepted. See, so it was first proposed by French chemist Henry Louis Chateaubriand, and it is proposed in 1885. So the setting reaction is explained on the basis of a difference in the solubility of hemihydrate and the dihydrate crystals. So the solubility of hemihydrate is not same as that of a dihydrate, and because of this, the saturation of hemihydrate is different compared to the dihydrate. So hemihydrate is 4 times more soluble than the dihydrate. So so what we do initially, there is little reaction. So after mixing the this dental gypsum dental plaster into the water, initially there is very little reaction, and thus there is little or no rise in temperature. This time is referred as induction period, and later there is a thickening of the mass, and which allows the mix to be poured as the amount of gypsum formed increases, and the mass thickens and then hardens into the needle-like crystals called ferrulites. And finally, the intermeshing of these crystals of gypsum lead to the strong solid structure. Sorry, we will see the crystalline theory again. So here we have seen up to this. After that, when the hemihydrate is mixed into the water, a suspension is formed which is a fluid and workable. So hemihydrate dissolves until it forms a saturated solution. See, we have seen that hemihydrate is more soluble than that of a dihydrate crystal. So obviously the dissolution of hemihydrate in the water is more fast than that of the dihydrate crystals. So it forms the saturated solution compared to that of the dihydrate is formed due to the reaction. So, since the solubility of dihydrate is much less, the hemihydrate solution, that is the saturated hemihydrate, is supersaturated with respect to that of the dihydrate crystals. So, any supersaturated solution is unstable. So, the dihydrate crystals are precipitated out, and this brings the solution to the saturation. So, this supersaturated solution tries to get saturated state, because any supersaturated solution is unstable. So with precipitation of dihydrate crystal, then it comes to the saturation. So as the dihydrate precipitate out, the solution is no longer supersaturated with hemihydrate, and so it continues to dissolve. The process continues until the hemihydrate converts into the dihydrate. So water powder ratio. The water powder ratio is very important factor in deciding the physical and the chemical properties of the final product. So example, the higher the water powder ratio, the longer is the setting time, weaker will be the gypsum product, and therefore the water powder ratio would be kept as low as possible, but the same time sufficient to produce a workable mix. See, we have seen that the crystals of the dental plasters are irregularly shaped and irregularly arranged. So in that case, we need more water compared to the dental stone, as the crystals are regularly arranged and densely packed. So the water powder ratio is again depend on the crystal shape and size. So as the water need of water increases, the properties are changed. That is, setting time is increased. As the water is increases, setting time is increased, and product which we get after mixing is of weak. It is not very strong. So the water powder ratio is very important factor in setting of the gypsum product. So water requirement of the product is affected by setting. I told you already that the shape and the compactness of crystal, thus irregular spongy plaster particle needs more water than the denser stone. So small amount of the surface active materials like gum, Arabic pulp, plus lime markedly reduce the water requirement of all the gypsum products. So particle size distribution and the grinding of the powder breaks up the needle like crystal and thus improves the packing characteristic and reduces the water need. This point we have seen during the manufacturing. So whatever the particle which we get after calcination, we can grind those particles to make a small particles. So the water requirement of water is again the reduced by this process. So recommended water powder ratio for is different for the different type of the material. So if for the impression plaster it is zero point 0.5 to zero point 0.7, dental stone zero point 0.4 to zero point 0.5, dental stone dental plaster impression plaster zero point 0.5 to zero point 0.7, dental plaster zero point 0.4 to zero point 0.5, dental stone zero point 0.2 to zero point 0.3, approved stone zero point 0.2 to zero point 0.2 4, and type 4 is it is again 0.18 to 0.22. So here the impression plaster requires more water compared to the type 5 stone. 5 stone. So again the properties of the material are depend on the ratio of water. So what huh. So whatever the water excess water, so in excess water, so the actual amount of water required for the reaction is very less compared to the water which we use for the mixing of the product. So here we can see the actual amount of water necessary to mix the calcium sulfate hemihydrate is greater than the requirement of the chemical reaction. So for the chemical reaction we required only 18.61 gram of water per 100 gram of a hemihydrate crystal, and this is called excess water. So basically excess water in short is what? The water which we use for the mixing is much greater than the water required for the reaction. So whatever the amount of excess we use for the mixing is called excess water. So the excess water itself does not react with the hemihydrate crystals. So the part of what is the role of excess water? So the role of excess water is only to help in a mixing of the product. It is not required for the reaction. So it is eventually lost by the evaporation once the gypsum is set. See, we have seen that gypsum, the setting reaction of the gypsum is of exothermic type of reaction. So the heat which created during the reaction helps in evaporation of the excess water, and after evaporation of the excess water the voids are formed in that place of the water. So the excess water serves only to aid in a mixing of the powder and particle and is replaced by the voids. Properties. The important properties of gypsum products are setting time, setting expansion, strength, hardness, and abrasion resistance, and reproduction of the details. Excuse me. So in the setting time, so mixing time. In setting time, there are three types of the time actually, the mixing, working, and setting time. So mixing time is the time from the addition of powder to the water until the mixing is completed. This is mixing time. And the working time is the time available a workable mix, that is the one that maintains an even consistency and may be manipulated, and generally it is 3 minutes, and the freshly mixed mass is semi-fluid in a consistency and quite free flowing and can be poured into the mold in any shape. And the setting time, the time elapsing from the beginning of the mixing until the material hardens is called setting time. So mixing time is what? The when we pour the dental plaster into the water and start mixing, and mixing is completed, mixing time. And working time is what? The material which we have mixed is in a state of molting consistency, that like we can pour, we can carve, is called working time. And setting time is time mixing time plus working times, that is the time elapsing from the beginning of mixing until the material hardens is called setting time. So again, the setting time is of two types: initial setting time and final setting time. So initial setting time is what? As the reaction proceeds and however more hemihydrate crystals react to form a dihydrate crystal, the viscosity of the mass is increased and it can no longer be poured. The material becomes rigid but not hard. It can be carved but not molded. This is known as initial setting time. So what is initial setting time? The reaction proceeds to to dissolve the hemihydrate crystals to form the dihydrate crystals, and the viscosity of mass is increased. So as the viscosity increase, it cannot be it is no longer pour, but it can be carved or it become rigid but not that rigid, so we can carve that particular thing. So this is called initial setting time, and in final setting time, the time at which material can sorry, the material can be separated from the impression without distortion or fracture. This is final setting time. So measurement of setting time again. So what we have seen in setting time is of two types, that is initial setting time and final setting time. And in setting what is setting time? It is mixing time plus working time. So setting time मध्ये काय, what is there in setting time? Mixing time plus setting time, working time is called setting time. Setting time is again of two type: initial and final setting time. So how we measure that setting time? So the measurement of setting time is done by uh, loss gloss method. As the reaction progress, the gloss is disappear from the surface. So whatever the gloss to the product is because of water. So as the reaction proceeds, the gloss is disappear from the surface of the plaster mix, and this is the loss gloss method. So exothermic reaction is again the one of the criteria to measurement of the mixing time. So we have seen that the reaction that is setting reaction of the plaster is exothermic type reaction. So the temperature rises of the mass may also be used for the measurement of the setting time. So as the setting time setting reaction is exothermic. So whatever the heat produced during the reaction is measured to measure the setting time. So this is exothermic reaction, one of the method to measure the setting time. Then the penetration test. These are of two types by using Wicket needle and Gilmore needles. See. This is wicket needle and Gilmore needle test. So in wicket needle, it the weight of the needle is 300 gram, and the needle diameter is of 1 millimeter. And the time elapsing from the start of mixing till the needle does not penetrate to the bottom of the plaster is setting time. So it should not penetrate the bottom of the plaster. So the setting time obtained with the wicket needle is similar to the initial setting time obtained by the Gilmore needle. This is Gilmore needle. So there are two type of the Gilmore needle. Okay. One is small and the other one is large. So the small Gilmore needle has 120 sorry 1/4 IV weight, and the diameter is 1.12 inch. And while the large Gilmore needle has one LV weight and the diameter is 1.24. So again, the time obtained by these needle is different. So initial Gilmore needle and the final. So initial, the time elapsing from the start of the mixing to the time when the point of the small Gilmore needle is no longer penetrate the surface is initial setting time, and in final, similarly, The time elapsing from the start of mixing until the point of the large Gilmore needle leaves barely visible mark on the surface of the set plaster is known as a final setting time. So this is setting time. Um, these are the methods of measuring the setting time. Now the factors affecting the setting time. The factors affecting there are the manufacturing process, mixing and spatulation time, water powder ratio, temperature and modifiers. So manufacturing process. In manufacturing process, again, the impurities during the manufacturing process and the fineness of the crystal. If the calcination is not complete, so that the gypsum particles remain, or if the manufacturers add gypsum, so the setting time will be shortened because of increase in a potential nuclei of crystallization. If the orthorhombic anhydride is present, the induction period will be
कॉलेजमध्ये जातात ना
it will be decreased if anhydride is present. So in short, if the calcination is not complete, there will be a calcium sulfate dihydrate. What is calcination? We convert the calcium sulfate dihydrate into the calcium sulfate hemihydrate, and if it is not complete, then there will be more crystals of calcium sulfate dihydrate. So that calcium sulfate dihydrate crystal act as a nuclei of crystallization and helps in a progressing reaction fast. So it decreases the setting time. Then fineness. The finer the particle size of a hemihydrate, the faster the mix hardens, particularly if the product has been ground during the manufacturing. Not only the rate of the solution of hemihydrate increased, but also the gypsum nuclei are more numerous and therefore a more rapid rate of crystallization, same as that of impurities. If the size of the particle is small, dissolution is fast, then nuclei of crystallization are more, so the setting reaction will be fast. So again, mixing and spatulation. Within a limit, the longer and the faster the plaster is mixed, the faster it will set because the